Okay, yesterday we learned how to find the derivative by using the quotient method, by using limits. So today we're going to learn lots of neat little shortcuts to find derivatives. This is going to make finding derivatives a lot easier. But before we do that, we need to go over some things from algebra. First of all, this needs to be an equal sign right here. If you remember, this is point-slope form of an equation, and today they're going to ask you to write the equation of the tangent line, and you're going to need to know this formula. So y minus y1 equals m times x minus x1. We're going to be using that. Another thing that you need to remember is sometimes when I have something like this, square root of x, I can rewrite that using an exponent. So the square root of x is the same thing as x to the 1/2. The cubed root of x is the same thing as x to the 1/3. The cubed root of x squared can be rewritten as x to the 2/3. 2 over x, so originally that was this problem. I can rewrite that. Anytime I want to bring something up into the numerator, I can rewrite that, but I have to change, this is to the first, I have to change the sign of my exponent. So I can rewrite this as 2x to the -1. So the first rule that we're going to learn is the constant rule for derivatives. It says the derivative of a constant function is always 0. So what's an example of a constant? Any number, okay? The derivative of 2 is 0. The derivative of 0 is 0. The derivative of pi is 0. Pi is just a number, 3.14. The derivative of e is a number, 2.71. 0. So that's easy. We like constants because the derivative is always 0. Then we're going to learn the power rule for derivatives. Here's how it's written in your book. If n is a rational number, then the function f of x equals x to the n is differentiable. We talked about that yesterday. And here's how you find the derivative. Okay, so look at this. You need to get used to being able to see what's in your book and know what they're talking about. The d stands for derivative. The bottom part, dx, tells me I'm in terms of x. So x is going to be my variable. Here's my problem. X raised to some power n. So look at what they did. They took my n and put it down in front, and then they subtracted 1 from that exponent. So here's the power rule in real words. Bring down your exponent, multiply if something is already in front, subtract 1 from your exponent. And then they're going to give us two derivatives for two trig functions. The derivative with respect to x of sine x is cosine x. The derivative with respect to x of cosine x is negative sine x. So we're going to look and see what these look like. Find dy dx for the following. So remember, this is just one way, one symbol to find the derivative. It's dy because I have y's in my problem. It's dx because if I had variables in my problem, I'm in terms of x. So I want to find dy dx. So one way I could write that, the derivative of this y. So I want to find the derivative of 7. 7 is a constant, so we just had any constant, the derivative is 0. Now right here, another way I could write derivative. Y prime, that's another symbol for derivative. The derivative of 0 is 0. Part C, the derivative of pi, pi is just a constant, 0. Part D, 2 pi squared. So 2 pi squared, isn't that just a number? This is actually saying 2 times 3.14 squared. That's just a number, so my answer is 0. So these were all examples of derivatives of constants. We like those, again, because they're all 0. Example 2, find dy dx for the following. So now we're getting into our power rule. So part A, I want to find the derivative of x cubed. The power rule says bring down your exponent in front, 3x, and then I just subtract 1 from my exponent, 3x squared. And that's my answer. Remember what derivative stands for. We're finding the rate of change or the slope of the tangent line to this equation. Okay, look at part B. Part B, here's your hint that I need to rewrite this. Anytime I have a fraction and in the denominator is a variable, I want to bring that up to the top. That's your first clue. Look at your fraction. Do I have any x's on the bottom? If you do, I need to rewrite it. So right now I have this. I'm going to rewrite that and I'm going to bring this up to the top. Now when I do that, it's 1 times this, so I'm going to get rid of my 1. But when I move it, instead of a positive 2, now it's a negative 2. So I haven't done any derivatives yet. I just rewrote the problem. So now I'm going to follow my rules for the power rule. Y prime equals. Bring down my exponent. Subtract 1 from your exponent. Negative 2 minus 1 is negative 3. Now, here's the rules for your answers. This is correct, but I never want you to leave negative exponents in your answer. So to fix this, I can move it again, and I'm only moving what has the negative exponent. And when I move it down, it changes it to a positive exponent. Part C. Part C is another problem I'm going to have to rewrite. My hint that I'm going to have to rewrite it is because I see that radical sign. So this was one of the examples on that first page. I can rewrite this as x to the 1/3. I haven't done any derivatives yet. I'm just rewriting. So now I'm ready to find the derivative. Y prime equals. Bring down your exponent. Subtract 1 from your exponent. So 1/3 minus 1 would be the same thing as 1/3 minus 3/3. That's negative 2/3. Now that's my answer, but remember the rules. We're never going to leave negative exponents in our answer. So everything's going to stay except what has my negative exponent. So I need to move that x. My x has to go on bottom, and now it becomes positive 2/3. Okay, part D. Part D, I can do each term, find the derivative of each of these terms separately. Alright, so y prime equals, I'm going to find the derivative of this. So bring down my exponent. Since I already have the 3 there, when I bring that 2 down, I need to multiply the 3 and the 2 together. So that's going to become a 6. Subtract 1 from my exponent, that's a 1 there, but since it's a 1, I don't have to show it. Minus, if this is a 1 right here, bring down that 1, I get 1x to the 0, and anything to the 0 power is 1. So the derivative of x is 1, plus, what's the derivative of 1? 1 is a constant, so the derivative of 1 is just 0. So I'm not going to put that 0 down. 6x minus 1. Okay, let's look at example 3. Find y prime for the following. Remember, y prime is just another symbol for derivative. Part A, y prime equals. These are all just the power rule. Bring down my exponent and subtract 1. 3x squared minus the derivative of 4x. That's like a 1 there. So bring down the 1. 1 times 4 is 4. X to the 0 is just 1, so the x goes away. The derivative of 5 is 0. So that's my answer. Okay, let me rewrite this one so you can see it a little better. This is negative x to the 4th over 2 plus 3x cubed minus 2x. Okay, so on this one, same thing. I'm going to bring down my 4. Y prime equals negative 4x over 2. I have to subtract 1 from the exponent, so it's to the 3rd, plus, bring down my exponent, so since there's something there, I multiply them together, 9x, subtract 1, so now it's to the 2nd, minus the derivative of 2x is 2. So we're just going to simplify this. Anytime you can simplify it, you will. That's going to give me negative 2x cubed plus 9x squared minus 2. Okay, my second part B, I don't know why this is B. I'm going to rewrite this. Again, if that's hard to see, that's a 3 right there. I'm going to move, anytime I see a variable in the denominator, I'm going to move it up. And you only move that variable. Okay, so I have my 5 on top, my 2 on bottom. Instead of my x cubed on bottom, I'm going to move it to the top, and it becomes a negative 3. So now I'm going to take the derivative, because I haven't done that yet, I just rewrote it. So y prime equals, bring down my exponent. Since I already have a 5 there, I multiply them together, so that's negative 15. I still have my 2 on bottom, x, and then subtract 1 from my exponent. Negative 3 minus 1 is negative 4. Our rule is we never leave negative exponents in the top. So I'm going to move that to the bottom. There's my answer. Okay, part D. I'm going to rewrite it first because I see an x in the denominator. So when I rewrite that, I have this. So y prime equals, bring down your exponent, 14, my 3 is still there. Subtract 1 from your exponent, 2 minus 1 is 1, and I'm done. Okay, E. Now this one looks a little different because I have x's on bottom and I have this weird radical. So I'm going to rewrite it, y equals. I know my 1/2 is okay. Remember how we write the cubed root of x squared? Or the square root of x squared? This is going to be x to the negative 2/3. So y prime equals, bring down my exponent. So I'm going to go ahead and write this out. Negative 2/3 times 1/2. Subtract 1 from your exponent. So up here, negative 2/3 minus 1, so negative 2/3 minus 3/3, it's negative 5/3. So I'm going to simplify. Y prime equals. When I multiply fractions, I can multiply straight across or I can cross cancel. This is negative 2/6 or negative 1/3. This has a negative exponent, so it can't stay. I have to move it. So I'm going to move it on bottom. And when I move it on bottom, it's now positive. Okay, on F. F is kind of different. I have an x on bottom, which I know I can't have. So the easiest way to do this one, to rewrite it, I can rewrite this as 4x cubed over x plus 3x squared over x. So when you do that, look what happens. Here, this x will cancel with one of these, and I just have 4x squared on top. This x will cancel with one of these, and I just have 3x. So now I'm ready to find the derivative. Y prime equals, bring down your exponent and subtract 1. The derivative of 3x is 3. Okay, find y prime for the following. So this right here, sine x is on your sheet. So look on your sheet and find the derivative of sine x. Okay, so on your sheet, the derivative of sine x is cosine x. So anytime you just have a constant in front, that constant's going to stay, and I want to find the derivative of sine x, cosine x. That was easy. Look at b. This is like a 1 in front, so I can actually rewrite this as 1/2 sine x. So if I want to find the derivative, the constant stays in front. The derivative of sine x is cosine x, and I'm done. Part C, I need to find the derivative of x plus cosine x. So I'm finding the derivative of each term. So y prime equals, the derivative of x is 1. The derivative of cosine x is minus sine x. Write the equation of the tangent line and the normal line to the graph of f of x at the given point. Right, so in order to write the equation of a line, we have to have two things. We have to have a point, which we do, and we have to have a slope. We don't have that. Then once we have those two things, we use the point-slope form to write the equation of the line. Okay, well we have our point, which is it's going to go here. Here's our point, but we don't have the slope. But we learned that the slope of the tangent line is the derivative. So the first thing we're going to do is find the derivative. So I have y prime equals, the derivative of this would be 3x squared plus 1. So that's the equation of the slope of my tangent line. To find the actual slope, I'm going to take this x value and plug it in. So when I take that x value and plug it in, 3 negative 1 squared plus 1, my slope is 4. So I know my slope is 4. I know my point is negative 1, negative 2. Now I'm going to take that information and plug it into this right here. So y minus y1. My y1 is a negative 2. So y minus negative 2 plus 2 equals my m, which is 4, x minus negative 1, so that's plus 1. So this is the equation of the tangent line. Okay, this is the equation of the tangent line at this point to this curve. Now the normal line is the line that's perpendicular to this. So back in Algebra 1 and Algebra 2, you learned that perpendicular lines have negative reciprocal slopes. So everything's going to stay the same for my normal line except my slope. Instead of 4, it's going to be negative 1/4. That's the equation of the normal line, or the line that's perpendicular to my tangent line. Okay, let's do another one. Change colors here. Okay, so part B. I need to find the derivative of this first. Now here's the thing. For this one, I have two things being multiplied together. So I need to multiply those out first. So I'm going to FOIL. That's going to give me x cubed plus x squared plus 2x squared plus 2x. And then just to make things a little easier, I'm going to combine these like terms. Okay, so I just rewrote the problem. I haven't done anything with derivatives yet. So now I'm going to find the derivative of each of these terms. So y prime equals, we're using the power rule, so bring down your exponent and subtract 1. 2 times 3 is 6, bring down your exponent, subtract 1, plus derivative of 2x is 2. So that's the equation of the tangent line. Now I want to know, I didn't give you the point, so we're going to use that same point. Negative 1, negative 2. So that means I'm going to plug negative 1 in place of all these x's. So So when I plug negative 1 in, I'm going to get 3 minus 6 plus 2. It's negative 3 plus 2, negative 1. So there's my slope. So my slope is negative 1. My point is negative 1, negative 2. And now I'm ready to write the equation of the tangent line. Y minus a negative 2, so that's plus 2, equals negative 1. X minus a negative 1, or plus 1. There's my tangent line. The normal line is going to be the exact same thing, but the negative reciprocal of this, the negative reciprocal of negative 1, when I flip it over and change the sign, I get positive 1. I think we have one more example. Determine the points at which the graph of the function has a horizontal tangent line. Okay. Horizontal tangent lines. Let me give you a quick example. If I have this function, and I wanted to draw the tangent line to, I don't know, a certain point. Horizontal lines have zero slope. So what they want us to do is, I'm going to find the equation of my tangent line by finding the derivative, and then I'm going to set that equal to 0, because I want to know where is the tangent line at slope 0. So let's find the derivative first. That's going to be 4x cubed minus 4x. There's the slope of the tangent line, the equation of the slope of the tangent line. So now I want to know, where is that 0? So I'm going to set that equal to 0, and now I'm going to solve that. So I can factor out of 4x, and I have x squared minus 1 left. If I set each of these factors equal to 0 and solve, on this one I get x equals 0, so there's one answer. When I solve this, I get x equals, and you have to be careful, plus or minus 1. So I have 3 points that I have a horizontal tangent line, and that kind of makes sense because I don't know what this graph looks like, but it probably looks something like this. So I have a horizontal tangent line here, here, and here. Okay, that's it, and I'll answer questions tomorrow.